Hey, physics students. Today I'm going to make a quick video for you all, just talking about work. What is it? What does it do in terms of energy? All that good stuff. I'm going to do a couple little demonstrations, talk about work. Right now, we know that energy is conserved. We learned that before break, that energy just gets transferred from one form to another. And so there's a couple of key points that I want to talk about. Energy, we often has to look at a system. So a system, let's say I have this action figure right here, this little pirate thing, and my wallet. Right now, let's just focus on the action figure. So the action figure, let's call the system. And that is the object contained within the system. As the action figure moves, energy can come into the system or out of the system. We can expand the system to then include the wallet, my whole house, the world, to the universe, right? And in the universe, right, there's no energy that's ever created or destroyed. Energy, however, can leave the system. So different types of energy we have are chemical energy, thermal energy, things like that, right? And so let's say this object, right, I heat it up in a microwave, it might melt a little bit, something like that, but it gets hotter. Well, what happens if it just sits here? Well, where does that heat energy go? It goes to the room, to the air around it, right? And so looking at just the action figure as the system, you would think that the heat is just leaving, it's disappearing, like where does that go, right? Well, when you zoom out to more and include more objects in a system, then we see that the energy is transferred from this system to surrounding objects. So in our physics problems, we investigate just one object or a small collection of objects to narrow our focus. So that's one quick thing in terms of a system. What work does is it puts energy into a system or takes energy out of a system. And so I'm going to do a couple of little demonstrations with this action figure here, and I'm going to just kind of take my screen and zoom it down. So here we go. Here's the action figure. It's chilling on my desk. And if I go ahead and it's sitting here, the action figure has zero kinetic energy, right? It is not moving, it has zero kinetic energy. Well, I'm gonna do work on this thing, and work is a force applied over a distance. So if I go ahead and apply a force, namely my hand, oh wow, we can't even see that, that went too fast. If I apply, right? I applied a force and that object sped up, right? And so I have increased the kinetic energy of this object by doing work on that action figure. So I have increased the energy of that system by doing work. So we add energy into the system doing work. Well, what can take energy out of a system? Well, many things. For one, friction. So again, same action figure. I'm going to do work to speed it up, and then watch what happens to this action figure. Well, why did it slow down? Why did that action figure slow down? It slowed down because friction was doing work on that object. Friction is doing actually what's called negative work, or what I like to think of it is work taking energy away from the system. And so where is that energy going? It's going into the table as friction, heat, into the action figure as heat. It's changing forms into thermal energy, but we're saying that friction is doing work to take energy away. Same thing with a roller coaster. The roller coaster will never be able to get to the same height as the highest point on the track. Why? Well, we have air resistance and we have friction on the track. We have air resistance from all the air molecules smacking into that roller coasters. And so what it's essentially doing is that friction, that air resistance, is taking energy away from that roller coaster car and reducing the total energy of that, let's call the roller coaster car the system. It's reducing the energy of the system. So we have less kinetic energy, and therefore we have less total mechanical energy for it to get quite as high as that first hill. There are situations in where total energy is conserved. And I'll demonstrate an example here. Right, if I drop this, I have all potential energy right now, right? And if I drop it, where does that potential energy go? Well, it gets converted into kinetic energy as I drop it and it falls down. And so here, all this potential energy gets converted into potential energy to right before it hits the surface. I hope that was helpful. Again, let me know if you have any questions, comments, concerns. This is just a quick video. Take a look. I'm going to share my screen here just really quickly. All right, so this is the page that is just above the video, internal versus external forces. That's going to help you do that next assignment. And so if you just read along, this talks about, you know, what I just basically talked about. Goes into a little bit more detail, but here's some great little ways to check yourself. You can, you know, see answer, it pops up, kind of gives you a quick quiz. And then same thing, positive versus negative work. I talked about positive work being putting energy into a system versus negative work taking energy away from a system. And so this is another quick quiz to see if you're on the right track, if you're understanding it. So that's a great little interactive thing to give you some instant feedback there. Let me know if you have any questions. I'm here to help. Just above on my Schoology page, I'll show you, is I need help what to do. Check that out. There's ways to get in touch with me there as well. All right. Hope you're all doing well. Look forward to seeing you all soon. Take care.